Last time we learned what momentum was, linear momentum, which was defined as the mass times the velocity. We also talked about the total momentum of a system of particles, and we talked very briefly about change in momentum. Today we're going to talk about how force and momentum are related, which we've already kind of touched on a little bit. We're going to define a new concept called impulse. We're going to talk about conservation of momentum and collisions, and we'll do one slide on conservation of angular momentum. So, as we said last time at the end of the last set of lectures, we know that we can get a change in momentum from a variety of different changes. Either you can change the velocity's direction, you can change the velocity's magnitude, or you could change the amount of mass you have in the system. Today we'll do examples of all of those different kinds. And again, we defined the momentum as equal to the mass times the velocity. So if we can change in the momentum, that means that we're changing that mass times velocity. For simplicity, let's just assume the mass is constant. And if that's the case, then we can pull the mass out of this equation, and we can say that the change in momentum is equal to the mass times the change in velocity. If you remember from when we first started kinematics, we defined a change in velocity as the acceleration times the change in time. What that means is that dv over dt equals acceleration. And you've seen that before. Using this, we can plug that into the change in momentum, and we can see that at the very beginning we have ma. If we remember that ma is equal to force, then we can say that the change in momentum is equal to the force times the change in time. We can think of it from another way. We can start with F equals ma, the second law. And again, remembering that A can be defined as change in velocity over change in time. We can write out the force as the mass times the change in velocity over delta t. And that gives us, again, the change in momentum over change in time. This is the exact same derivation that we just did in the last slide, just from the other way around where we think about force first. So this is Newton's second law as he stated it, which is that force is the change in momentum over change in time. It's also the second law in terms of momentum. So before we said F equals ma, and now we know that that's also equal to the change in momentum over change in time. And this is something that we've been hinting about on Monday, but in actuality we can kind of see it confirmed, which is that when you change the momentum, you can only do so if you have a force. And so that makes sense because velocity can only change if there's an acceleration. By definition, a changing velocity means that there is an acceleration, and you only have an acceleration when you have a force, which we've said since the second exam material. So this all hangs together, and you can see now that conservation laws can actually give us a lot of the information that we had about dynamics, and can ultimately lead us to the kinematics that we started with at the beginning of the class.